Geometry students, in this video I'm going to walk you through the key concepts from Unit 6. First we'll start with transformations. In this first example, I'm starting with a triangle that's got 3 points. The points are 1, 1, 4, 1, and 4, 5. And I'm going to perform a reflection over the x-axis. And to do that, I'm going to make the y value negative. So my points would be 1, -1, 4, -1, and 4, -5. And when I plot those, 1, -1, 4, -1, and 4, -5, I will end up with a mirror image of my triangle flipped over the x-axis. Then we will reflect it over the y-axis, and to do that we will make the x values negative. So we'll get -1, 1, -4, 1, and -4, 5. And then I will plot those. And we'll have a reflection over that vertical y-axis. Okay, moving on, we're going to do a dilation. I'm going to do a dilation with a k value of 2. That means that I'm going to take the points, each xy, and I'm going to double it. So for the point 1, 1, I'm going to double both of those, and I'll get 2, 2, and that takes me to right there. The point 4, 1 will become 8, 2. Unfortunately, this is off of my graph here. It'll be over there. And then 4, 5 is going to go to 8, 10. And that's going to be way off the page, but we're going to end up with a triangle that looks something like this. And you'll notice that the length of each leg doubles. So this one is 3 units, and then the dilated is 6 units long. Rotation 90 degrees counterclockwise. Pay special attention to this one because it is foundational to perpendiculars. So here we're going to switch the x and the y and make the y negative. So again, my points, I'll write those down. And then what I'm going to do is swap the x and the y. So I'm going to put the y first. These are the y's. And then I'm going to make them negative. And then the x values I'm going to put second. So that's 1, 4, 4. And then I'm going to graph those points. -1, 1. -1, 4, and -5, 4. And I'll end up with this triangle has rotated 90 degrees counterclockwise around the origin. One thing I want you to pay special attention to are what are the slopes that we see here. The slope of the hypotenuse of the triangle. Slope is rise over run. So the slope of this is going to be 4 over 3. How about the slope of this hypotenuse? The slope of that is going to be the rise over the run, and the rise is -3, and the run is 4. And what we see with these slopes is that they are what we call opposite reciprocals. They're opposite because they have opposite signs. One's positive and one's negative. And they're reciprocals because in one of them it's 3 over 4, and the other one, the numerator and the denominator have switched, and it's 4 over 3. All right, let's keep it rolling here. Let's find this rotation of 180 degrees. So I'm going to start with my same points. and I'm going to make them both negative. Oops. And then I'm going to graph them. -1, 1, -4, 5, -4, -5, pardon me, and -4, -1. I was going over first and then down. That's a rotation 180 degrees around that origin. A translation. For a translation, I'll make up some numbers here. We're going to take our points, 1, 1, 4, 1, 4, 5, and we're going to apply this rule. We're going to take x and we're going to add 2 to it, and we're going to take y and we're going to subtract 3 from it. And that's going to be a translation of 2 units to the right and 3 units down. So the x coordinate of 1 plus 2 gives me 3. And the y coordinate of 1 minus 3 gives me -2. So that's my new coordinate. So when I plot 3, -2, I end up right there. And what's happened here is my point, 1, 1, has moved over 2 and down 3, corresponding to that rule. Okay, so let me finish this up. I'm going to take 4 plus 2, that's 6. I'm going to take 1 minus 3, that's -2. I'm going to take 4 plus 2, that's 6. I'm going to take 5 minus 3, that's 2. And then I'm going to plot those points. So 6, -2, and 6, 2. And I've scooted the whole triangle over 2 and down 3. Let's take a look at this centroid. Here's a new triangle. The coordinates of this triangle are 1, 1, 7, 1, and 7, 7. And to find the centroid or center of gravity, there's 2 steps. The first step is to find the midpoints of each side. In this example, the midpoint of the bottom side is 6 units long, so the midpoint's right in the middle. So I'm drawing those midpoints. And then I'm going to draw a line between the midpoint and the opposite corner. Between the midpoint and the opposite corner. And this intersection point is called the centroid, or the center of gravity. It's a special point on the triangle. All right, turn the paper over. Let's talk about circles. I can justify and apply the properties of a circle. We're going to look at the equation of a circle. The equation of a circle is right here. These letters, H and K, represent the center of the circle, and R is the radius. So let's graph the circle with center 2, 4. That's giving me H and K, and my radius of 4. So to do this, I'm going to write out the formula for a circle. And then I'm going to plug in 2 for H, and I'm going to plug in 4 for K, and I'm going to plug in 4 for R. So again, I got those values from here and here, and I plugged them in. Then I'm going to graph this circle. So the center is at 2, 4, so I go over 2, up 4. And the radius is 4, so I'm going to measure out 4 units in all 4 directions. And then I'm going to sketch that circle. It might be helpful to have a compass. There it is. Then it says to dilate the circle with scale factor 0.5. So scale factor 0.5 means that the radius is going to be half of 4, and half of 4 is 2. So the center is going to remain the same. And let me see if I can draw this. There's my circle with radius 2. The center is the same, so I still have an H of 2 and a K of 4. But my radius would be 2 squared. Oops, I have an error here. This should be an equal sign. Okay, let's close this out with writing the equation of a line. We've got three ways to write the equation of a line. Slope-intercept form. Slope-intercept form, m is the slope, b is the y-intercept. And then we've got this thing called point-slope form. In point-slope form, m is the slope, and the point is x1, y1. Also, we learned in this unit that parallel lines have the same slope, and then perpendicular lines have slopes that are opposite reciprocals, like we saw on the front page. So this question says, write the equation of a line that is perpendicular to y equals negative 2x plus 3 that passes through the point negative 1, 4. Now, ultimately, I'm going to use point-slope form to do this because I have a point. The point that I have, x1, y1, is equal to negative 1, 4. So that means that negative 1 is the x-coordinate of my point, and negative 4 is the y-coordinate of my point. So if I'm using point-slope form, oops. So I'm just copying down that formula again. I can actually plug in negative 4 for y1, and I can plug in negative 1 for x1. Now, when I subtract a negative, it becomes a positive. When I subtract a negative, it becomes a positive. And now there's just one thing I'm missing from my equation. I need the m value. I'm going to get the m value from the line that they gave me. The line that they gave me has a slope, and that slope is negative 2. But now what I need is the perpendicular slope. So my original slope of the given line is negative 2. The perpendicular slope is the opposite reciprocal. So I'm going to take the negative 2 and I'm going to do two things to it. One, I'm going to take the opposite, turn it positive. 2, I'm going to take the reciprocal, and the reciprocal of 2 is 1/2. And one thing to think about is with a whole number, to take a reciprocal, think of the whole number as being over 1, and then the reciprocal, reciprocal means to switch the numerator and the denominator. So the slope that I need to put into my formula is 1/2. And there's my equation. Let's go ahead and graph this. This line goes through the point negative 1, 4, and then it has a slope of 1/2. The slope of 1/2 means up 1 over 2, up 1 over 2. So if I were going to sketch the graph of this, it would look something like that. Here's another coordinate plane question. Does the point negative 1, 4 fall on the circle with centers 2, 0, and radius 5? I'm going to start by writing an equation for the circle. X minus h squared plus y minus k squared equals r squared. I'm going to plug in 2 for h. I'm going to plug in 0 for k, or you could just leave it because 0 doesn't change anything there, equals 5 squared. I'm going to take this point and I'm going to plug it in. I'm going to take negative 1 and put it in for x, and I'm going to take 4 and put it in for y. So I would get x minus, whoops, I messed up. I'm going to put a negative 1 minus 2 squared plus 4 minus 0 squared equals 5 squared. And I'm going to keep going here. Negative 1 minus 2 is negative 3 squared. 4 minus 0 squared is 4. Negative 3 squared is 9. 4 squared is 16. Check it out. This is a true statement. Since this is a true statement, yes, the point falls on the circle. If I got something that was not true, like if the radius of the circle wasn't 5, if it was 6, then this would be a false statement, and we would say the point does not fall on the circle. Okay, last two reminders here. Horizontal lines. Horizontal lines are always of the form y equals. So a horizontal line passes through that passes through -5 is of the form y equals -5. That means all of the y values are -5, and if you have all of the y values -5, it looks like that on the graph. Vertical lines are of the form x equals, and that would be x equals -2, and they would fall, it would look like that on the graph. All right, reach out to me if you have any questions, and thanks for following along on the Unit 6 review.